All right, at this time, I would like to introduce Dr. Paul McKinney, our Professor and Associate Dean for Research at the University of Louisville School of Public Health and Information Sciences. He's going to introduce our speaker today.
Thank you very much, Paige, and good afternoon and welcome to the final installment of our four-part Woodson lecture series for the current academic year. We're very grateful that Dr. Luby will be sharing with us how preventing human extinction is a public health priority. I want to take a moment to acknowledge the series is being funded by the Woodson Lectureship Endowment, established with an anonymous gift in 2014. I also want to thank the leaders in our school's Student Government Association, who were instrumental in pulling together this webinar series, as well as the team in the Office of External Affairs for handling event promotion and registration today. So for the last 30 years, Dr. Stephen Luby's research efforts have engaged a broad array of health issues in low-income countries. Dr. Luby currently serves as the Director for Research of Stanford University's Center for Innovation and Global Health. He's also appointed as Professor of Medicine and Infectious Diseases and a Senior Fellow in Stanford's Woods Institute for the Environment and the Freeman Spogli Institute for International Studies. Earlier in his career, he lived in Pakistan for 5 years and Bangladesh for 8 years. Dr. Luby is a prolific researcher who, by working closely with local collaborators, has conducted very extensive work assessing pandemic risks and strategies to reduce these risks. He teaches a popular course to Stanford's freshmen entitled Preventing Human Extinction. So without further ado, I present to you Dr. Stephen Luby.
Well, thank you very much, Paul, for that introduction. First, I just want to check, can you all see my slides?
Yes.
Well, great. This is actually not the most uplifting topic to end your lecture series on, but I appreciate the opportunity to talk a little bit about what I see as a key issue for public health to engage. So why, when given this opportunity, do I think that we should talk about a subject that is as depressing as the prospect of human extinction? Well, first is because the threat is genuine. 99.9% of species that have ever lived on Earth are extinct. That's what species do. So this threat is genuine. It is inbred with us as being a species. And maybe is it even heightened risk now, not only ever becoming extinct, but the threat of imminent extinction. If we think about it, there are 13 Homo species who have roamed the Earth. 12 of these have gone extinct. Does it really seem like the one Homo that has developed the tools for nuclear Armageddon is immune from the fate that's befell all other Homo species that have inhabited the Earth? And yet, despite the credibility, and I would argue the urgency and importance of this threat, it's not widely discussed critically and seriously. And addressing these threats actually does require careful thinking, lots of perspectives, and a progressive discussion. It's actually a good fit for a university. So I want to suggest that by 2100, there are 4 potential scenarios that humanity may be in. First, Homo sapiens may be extinct, just like the 12 other Homo species that preceded us. Alternatively, we may face huge calamity and human civilization may collapse. We may be thrown back into pre-agricultural times, but some people may survive, at least for a while. Alternatively, there could be a catastrophic decline, but maybe some cities and some institutions would persist. Alternatively, we could have a thriving human society, unbelievably better than even where we are now. So we're in 2022, and I want to think about the potential future over the course of the next 78 years. And I want to organize this by addressing a few questions. First, is there a substantial risk of imminent human extinction or catastrophic collapse? Second, can we influence this trajectory? Third, how might we improve the prospect for a human future? So I want to begin by thinking about the central role that technology has played in human history. Technology really has been a central force. It has allowed us to go from hunter-gatherers to raising agriculture and building cities and increasing population. Technology builds on earlier technology. Once you have a harness, then you can develop a plow. Because of this building on top of prior achievement, technology development is inherently exponential. And we see this most famously in Moore's law. Gordon Moore was the co-founder of Intel, and he noted that the number of transistors on integrated circuits doubles approximately every 2 years. And so that this has really led to an exponential growth in computer capacity. And we think a lot about this in terms of Moore's law, but I think we should recognize that it's not just about integrated circuits. For example, if we think about hard drive capacity, when I joined the Centers for Disease Control in 1990, I was issued a computer that had a 20 megabyte hard drive. Now, I was thrilled that my computer had a hard drive, so I didn't just have to reboot the operating system from floppy drives all the time. The laptop that I'm presenting on what's now this afternoon in Louisville has a 2 terabyte hard drive. So that's a 6 order of magnitude increase over the course of 30 years. So really right on this exponential growth. And we see this because the y-axis here is in logarithmic form. And similarly, we see an exponential growth in lots of other areas. This is non-commercial flight distance without refueling, or the number of human genome base pairs that can be sequenced per US dollar. So we have really seen this remarkable exponential growth with technology. And if we go back through human history, what we see is that progressive technology development has really enabled human population expansion. So the agricultural revolution occurred, probably about 10,000 years ago, 10 or 12,000 years ago in various places. It was several thousand years before the plow was invented. But with the plow, within a few hundred years, there were the first cities. And then we saw metallurgy and writing rise. But the big changes occurred around the time of the Industrial Revolution. The Industrial Revolution, which allowed both the harnessing of fossil fuels and then remarkable number of technologies, one that built on the other, really led to an explosion of human population, a growth in human population that very much follows Moore's law in terms of the number of people living on the planet. And if we look at this, it's not just that technology is accelerating, but the rate of change is also accelerating. So by the end of the 20th century, we were making 5 times as much technological progress per year as the average over the century. So technology, I'm arguing, is a super force in human history. It has this inherent capacity for exponential growth, and the cost per unit of capacity is dropping. And we really have seen great promise coming out of technology. If we look at world production of cereals, we were able to avert global famine, particularly across Asia in the 20th century, by markedly improving cereal production. And that was a result of a number of technologies, including selective breeding, so-called Green Revolution strains, as well as additions of fertilizers and pesticides. So we have seen technology really support the growth of human thriving. But we also see technology's peril. The technologies of mass destruction are also becoming cheaper, easier, and more widely available. So I'm going to talk about 4 imminent threats to human survival. And the first threat is from violent self-destruction. So humans have repeatedly demonstrated that they are willing to kill millions. These human remains are from the killing fields from the Khmer Rouge in Cambodia in the mid-1970s. But there are multiple places where humans have been willing to kill other humans on the scale of millions. What's different now is that the technology to precipitate mass murder is also expanding exponentially. We now have the power to kill more people. The biggest threats, of course, the most potent weapons in the earth are nuclear weapons. Whereas of 2017, about 7,000 nuclear weapons in Russia, about 7,000 in the US, with lesser numbers in several other countries. And if we think about what happens if we deploy these weapons that we use, this is an assessment from the US Office of Technology, where they looked at a US attack targeting Russia's nuclear forces. So not trying to kill civilians, but just trying to take out Russia's forces so that there would be a preemptive attack. This would require the US launching 20% of its arsenal, and it would take about 30 minutes. The planned Russian military response to this massive attack would be they would launch. And so as the US Office of Technology thought through this, they would predict an immediate mortality of between 1/3 and 3/4 of the US population and about 1/3 of the Russian population. So these are US estimates of what would happen in a nuclear conflict. And that's just the acute results. If we look at what would happen because of one of the consequences of nuclear attack is that you incinerate cities, and this drives the ash from cities up into the stratosphere. The stratosphere is above the level of cloud, so it doesn't get rained down. So that layer of cloud, that layer of soot, blocks the sun. So if we have a smaller nuclear exchange, say 3% of the global arsenals of the size that would be expected, for example, with a nuclear exchange between India and Pakistan, we would see about a 1-degree drop in global temperatures. Estimated population loss from this kind of exchange, $1 to $2 billion, driven 1 to 2 billion deaths, driven primarily by subsequent declines in agriculture. If we think about a larger exchange with more nuclear weapons, then we see greater reductions in global temperature. And if nearly all of the global arsenal is released, we see 7 to 8 degrees decline in temperature. So what does this look like? So this is the change in degrees centigrade 1 year after 95% of nuclear arsenals are detonated. And what you can see is that the minimum daily temperature in Ukraine and Iowa dropped below freezing for more than a year. So the temperatures across North America would drop by 20 degrees and across Eurasia by 30 degrees. So complete interruption of agriculture in the world's bread baskets. And it's not clear that humanity could survive the cascading disaster here. At the very least, this would be profound civilizational insult and potential collapse. But there are also other violent threats to humanity. Nuclear war is actually relatively expensive and requires very high technology to implement. But now we have increasingly potent technology that's just available very easy. Facial recognition is widely available. We can use it to sign into our phones and our laptops. And of course, cheap drones are also available. And as Max Tegmark points out there isn't much difference between a drone that can deliver Amazon packages and one that can deliver bombs. Moreover, with artificial intelligence, drones can work together. A guided capacity to communicate, coordinate, and adapt that makes them very difficult and very powerful. So we could imagine an artificial intelligence powered bumblebee-sized killer drones. They could be programmed to kill cheaply with minimal explosive power by shooting people in the eye or injecting a potent toxin. They need only the same level of autonomy as a chess program, so not very high tech, with a goal of winning the game and the ability to choose targets and implement moves. So as we think about the exponential growth in technology, this increases the destructive capacity of individuals and groups who want to do harm, and it reduces the cost. So as military thinkers consider this, like Paul Charest, he argues we're entering a world where the technology to build lethal autonomous weapons is available not only to nation states, but to individuals. So turning from the threat of violence, I want to now look at environmental destruction as an imminent threat. So this is an image of the Aral Sea. It was formed 20,000 years ago and was the fourth largest lake in the world. It was a thriving ecosystem where there were 34 species of fish, and it provided a sixth of all fish to the Soviet Union and 500,000 muskrat pelts. This was a really thriving ecosystem. In the early 1960s, government authorities diverted the two rivers feeding the Aral Sea so that they could make more money growing rice, cotton, cereal, and melons. So here is an image 15 years later. I mean, the Eastern Basin isn't even, I mean, it's not even called the Aral Sea anymore. It's the Aralkum Desert. Salinity has increased 20-fold in the remnant of the sea that survives, and 32 of the 34 species has died out. And the Aral Sea is a dramatic example, but it's actually part of a broader pattern that's happening globally. This is an image of global land surface freshwater, and although it's counterintuitive, the bright blue are places where water is being lost. So between 1993 and 2007, looking globally, we have lost 6% of our global surface fresh water, and the largest declines have been in areas of largest population growth. So fresh water that we depend on and these lakes and these rich ecosystems are really disappearing globally. Consequences of the environmental change includes widespread biodiversity loss and increased extinction in the animals in the whole range of life on Earth. And if you look at the timeline for the increase in extinctions, it really follows that same exponential curve that we see with the Industrial Revolution. As the Industrial Revolution has come, and as humans have taken over more and more of the Earth's land area and the Earth's primary production, other creatures have been squeezed out, literally. So the Earth's biosphere is a complex, interactive ecological system. It's resilient to countless perturbations, but anthropogenic actions risk permanently destabilizing these long-standing, resilient Earth systems. So Stefan and colleagues have advanced this notion of planetary boundaries, that there's a safe operating space for humanity. And if we get beyond this safe space, then our biosphere becomes so compromised that the human future is compromised. And so as we think about the losses to biodiversity that come from the loss of genetic diversity have been so profound that Stefan ranks this as at very high risk. We have also altered the phosphorus and nitrogen flows through the work through agriculture and with dead zones in the ocean, and again, at very high risk, and climate change also getting worse and worse. So concerns that there are multiple ways that we are mismanaging the biological home that is the biological basis of a thriving human community. A third risk, imminent risk to human survival, is synthetic pathogens. So we have been impressed with a number of technological breakthroughs in synthetic biology, including DNA sequencing, automatic DNA synthesis, gene editing, and gene drive. As Andrew Murray was quoted in Scientific American as saying, look, molecular biologists have developed the amazing ability to manipulate DNA. Swapping out genes has become as routine for them as making coffee in the lab kitchen. So playing with genomes and manipulating genomes has been a very powerful technology. But I want to focus a particular risk here is manipulating genomes to make pathogens. So the scenario of particular concern is that a malicious actor could start with an influenza virus, like influenza A H5N1. Influenza A H5N1 is a poultry specific virus. A few hundred humans have been infected. When they do, half of them have died. Influenza A H5N1 can be transmitted person to person, but it's quite inefficient. But if transmission efficiency were improved, for example, if there was gain of function genetic engineering so that it worked better at transmitting from person to person, because we are so connected as a planet, these are this is an image of all of the flights that connect us. And as the SARS-CoV-2 outbreak demonstrates, we are all connected and we could face a devastating global pandemic. And I realize that we all feel right now with SARS-CoV-2 that we sort of have pandemic fatigue, and okay, we've known what that is, but SARS-CoV-2 has had a case fatality rate of about 2%. So thinking about what would happen if we had a true high mortality epidemic around 50% with fast transmission, this would truly be devastating. So there are countless worrying gain of function scenarios. And I would submit that there's no shortage of sociopaths in the world that would be willing to deploy one or more of these. The concern here is that the potency of tools to synthesize new pathogens just keeps getting more and more powerful year to year, and the cost and the skills needed to deploy these, the costs are going down, and the skills needed to be able to work in this area are decreasing. So the number of people who are able to construct novel, deadly pathogens is growing exponentially. There's a biohacker community that has been increasingly active. As one representative of this community, Keone Gondal, explained, I just wanted to clone DNA using my automated lab robot and feasibly make full genomes at home. A team from University of Alberta recreated an extinct relative of smallpox, horsepox, by using mail order DNA in just 6 months for about $100,000. So this is a growing threat. Fourth threat I want to mention is artificial superintelligence. I've talked a little bit about how artificial intelligence could make other threats worse, but I want to talk about artificial superintelligence. So when we think about intelligence, I think we commonly think about some people, say Jane Goodall, is more intelligent than other people, the character of Homer Simpson. So I kind of think about intelligence on a human level, but I want us to think across a broader range. So this is a Colorado potato beetle. So the Colorado potato beetle demonstrates some intelligence, and there are some potato beetles that look to be better than others at finding food and finding mates. But potato beetles are not nearly as intelligent as say, the particle physicist Persis Drell. I mean, there are orders of magnitudes difference in the way a potato bug goes through the biosphere versus a human. Average human brain can juggle 7 discrete chunks of information simultaneously. Geniuses sometimes up to 9. And by this, we can outperform other animals. We can certainly outperform potato bugs. We can outperform other primates. But juggling 7 is rather arbitrary, is a hard cap on the complexity of thought. Imagine an entity that doesn't just juggle 9, but can sift through 90 concepts at once and immediately recall trillions of bits of data. It would actually be a whole new order of mental landscape. There would be as much difference between this entity and us as between a potato bug and a human. So if we look at current artificial intelligence systems, we see that in narrow domains, they are already substantially outperforming the best humans. Physically, they're better at heavy lifting and precision welding, though humans still do better at diagnosis and planning and fine motor skills. Audio translation, the best humans are still better, but artificial intelligence keeps getting better. When we look at mental games, computers can now beat the best humans in Jeopardy, in chess, in Go, and in many Atari games. And they're better at verifying theorems than are people. So although the accomplishments of artificial intelligence in narrow domains are in more and more domains are outperforming people, we don't yet see artificial general intelligence. That is a computer that could do all of the things that humans can do. But we can certainly imagine a superintelligence, an intellect that's much smarter than the best human brains in practically every field, including scientific creativity, general wisdom, and social skills. And so if we reached artificial human level general intelligence, added additional intelligence, we would have artificial superintelligence. And this could develop incrementally as the chess playing computer combines with the language translating computers. And so we might slowly get there, or it could be explosive. It may grow very fast. Potential tipping point is when an artificial intelligence develops the capacity to improve the design of artificial intelligence, so it could improve itself. And with recursive self-improvement could lead to an intelligence explosion over a matter of days or weeks, or even hours. So superintelligence might be impossible, but there's no clear physics barriers. And artificial intelligence already exceeds human intelligence in narrow domains. Machine intelligence also has certain advantages. It doesn't require thousands of years of evolution to implement and upgrade. And the ultimate limits of hardware performance are vastly higher than biological computing, and it has an ability to share, edit, and duplicate. So there's a widespread myth that artificial intelligence can't control humans because humans would be doing the programming. But in fact, it's total intelligence that enables control. We control tigers by being smarter, not by being stronger. So if we cede our position as the smartest on our planet, it's possible that we might also cede control. So you're probably not an ant hater who steps on ants out of malice. But if you're in charge of a hydroelectric green energy project and there's an ant hill in the region to be flooded, too bad for the ants. Or as Marshall Bain says, in the presence of human intelligence, superintelligence, humans will become as irrelevant as cockroaches. So the myth is that machines can't have goals, but we already know that a heat-seeking missile has a goal. So machines certainly can have goals. There's a worry that artificial intelligence might turn evil or might turn conscious. But I would argue that the real worry is that artificial intelligence would turn competent and it would have goals that are misaligned with ours. So I've outlined 4 existential threats: violence, environmental destruction, synthetic pathogens, and hostile artificial intelligence. I would say the most common response to these threats is largely to ignore them. We don't have these conversations. There's not a class at Louisville that discusses these. And I would argue that there are barriers to serious thoughts on existential risks, including both the psychological discomfort, who wants to talk about this, the deep epistemological uncertainty, we don't know what will happen. We have cognitive biases that discourage us from thinking about it, and a real short-term orientation, both as individuals and socially and politically. So one response to the concern that these existential threats are unlikely, at least within the next few years, and therefore we should focus on more immediate concerns, is to encourage you to consider both the probability and the impact of future scenarios. So we could imagine, for example, that there's no celebrity gossip available today on social media. Well, I would argue that's a very low probability. But even though it is low probability, it's low impact. So we in public health don't need to worry about it. Similarly, is there going to be rain in Louisville this month? Well, very high probability there'll be more rain in Louisville. But the impact of more rain is pretty low. Louisville is used to wet springs. By contrast, there's a very high probability of climate change, and it will have a high impact on global health. And therefore, attention to climate change is clearly warranted. But there are also many existential risks that sit here that are high impact, but low probability. For example, that somebody will do a gain of function with H5N1 and release this pandemic, or that we will see artificial superintelligence within the next decade. So the impact could be very high, but the probability is lower. But it's a mistake to focus solely on probability. For example, prudent action should be guided both by probability and impact. When you get in a car, you put on a seatbelt. You don't say, well, wait a minute, the probability of me being in a high velocity collision is low, therefore it's not worth the time for me to put on a seatbelt. No, it's a low probability, but you protect yourself by putting on a seatbelt. So in that occasionally low probability, potentially catastrophic event, you're protected. But our cognitive biases discourage attention to low probability events. People tend to rebuild on floodplains after a generation or two because they didn't recall seeing the floods. So a question is, if we take these threats seriously, can we influence the trajectory? Or are they so baked in that there's nothing we can do? Well, I would argue that there have been notable historical achievements, that people working together consciously and deliberatively have addressed hard problems and improved the human future. After 360 years of African slavery in North America, human slavery was abolished in the US in 1865. Now, I'm not arguing that this has solved all of the problems with racism in North America, but we are better off having abolished slavery. Similarly, in 1893, New Zealand became the first country in the world to give women the right to vote. And this notion has really spread globally over the course of the last 130 years. Now, 193 of 198 nations allow women to vote in national elections. Lead exposure results in marked irreversible impairment of intellectual function. There's no safe level. It causes lots of adult diseases as well. And yet it was in our gasoline and heavily promoted by fossil fuel companies. Now, some scientists eschewed industry funding They looked at the lead concentration in Greenland ice cores, and they noted that lead had gone up since it had been put in gasoline. At the US Environmental Protection Agency, the issue was delegated to 2 young, newly hired, inexperienced staff who worked on this. And ultimately, the elimination of lead from gas is one of the great environmental achievements of all time. So I would argue that we have had success in improving the future when we have focused on it. So how might we affect this trajectory at this time? Well, most people think we need something new, maybe a new technology that could help, or a new approach to governance, to social movements, to spiritual conversion, or political leaders. And I find people immediately say, oh, all right, well, there are these threats, but there's something we can do. But they're looking for a panacea. So Panacea is a Greek goddess of universal remedy. And just like Santa Claus isn't real, Greek goddesses are not real. And I would argue that a belief in panaceas is a cognitive error. The threats that threaten the human future are threats that arise from a complex system. And so that we need to work diligently to try to reduce these threats. But it's not hopeless just because there aren't panaceas. Leading thinkers on each of these threats have proposed tractable steps towards prevention. I argue that public health offers a useful framing to address existential threats. Public health, the core value is social justice. Public health is concerned with the health of all people, and this includes concern with future generations. Public health has worked towards a better future, a future where fewer people die, where there's less pollution, where there's less lead in the environment, where there is less disease. And public health has a strong prevention focus with many successful achievements. I see universities as key institutions to counter existential threats. Universities have the freedom to consider long-term issues where politicians have to worry about the next election and private businesses have to worry about the next quarter results. Universities can dig deep and consider long-term issues that offers the sophistication of getting different people from different disciplines together to talk about it. There are motivated students who are interested, and they really can be centers of creative problem solving. So as individuals think about ways they can contribute, this of course depends on the skills, the interest, the perspective, and connections that you bring. And so I encourage you to think about your leverage points within the complex systems that can mitigate some component of these catastrophic threats, and whom you can find to engage with. So I would argue there's a broad array of research: engineering, economics, health systems, political science, history, earth science, law and international relations, that all can work to reduce the threat of imminent human extinction. Businesses can provide services that support the human future rather than that degrade the environment, that actually preserve and build natural capital. Education can be used to both open minds so that we can address these problems, develop skills, and encourage a pro-social contribution. There's roles for advocacy, both as spokespeople, but also as organizers, and encouraging constructive conversations, use of the arts and fiction to envision a better way forward. Looking at laws, how we can improve the system and how we can have laws that can advocate for the human future. And government service also can help to bring political change, improvements in technical capacity, and improving decision-making, and lots of other ways as well. So in conclusion, humanity faces a substantial risk of imminent extinction. We may be able to influence this trajectory. And so I encourage us to consider allocating time, attention, and resources to these concerns. So how much might we accomplish if we reallocated 10% of the time and attention that we dedicate as spectators to the daily news cycle, and instead lean in towards efforts to prevent extinction, and to really integrate these concerns in our societal discourse, and to explore where we have agency to counter these threats. Thanks.
Dr. Luby, thank you very much for joining us today and sharing your expertise and perspective on your 50 plus years in the field of global public health. And we also want to thank all of those who joined today, this afternoon, here in Eastern time anyway, including our university colleagues, alumni, students, state and local public health professionals who were on the webinar. Before we conclude and open up the field to questions and answers, we want to virtually present Dr. Luby with a very small token of our appreciation. And Paige, do you have that for us? Ah, yes. On behalf of the University of Louisville School of Public Health and Information Sciences and Student Government Association, we'll be sending Dr. Luby a genuine Louisville Slugger bat because he indeed is a heavy hitter in this field. Dean Blakely was unable to attend today, but we do have a picture of him with his own Louisville Slugger there practicing in his office. As a devoted baseball fan. We do appreciate you all taking the time to be here with us today, and Paige will moderate the questions and answer session from participant questions via the chat. For everyone else, we appreciate your taking time and hope to see you again during the next round of the Woodson Lectures.
Definitely, thank you. Feel free to drop any questions in the chat. I see some raised hands too, so I can unmute people if you prefer to ask. So it looks like Dr. Joy has a question, so I'm going to unmute him.
Thank you, Professor, for that extremely interesting and quite terrifying presentation. One of the most powerful ones I've seen in a long time. I have a question about human perception and human behavior that you might address. We know from the study of risk perception that dreaded outcomes and events that affect future generations are some of the most powerful contributors to our perception of risk. In fact, we tend to overestimate risks that affect that. On the other hand, we also know about intertemporal choice, where we tend to value things that are most immediate to us rather than long-term. How do we bridge the gap between those two events, those two facts, to get people to take steps today that may influence the future?
Yeah, well, thanks a lot for the question. And I think it really gets to the core of the challenge here. And there's a balance between putting out these threats in ways that people can understand. So, and not just shut down. So I'm pleased that that people were willing to stay on and hear it. But at the same time, then how do we get a constructive response? And there are a group of human biases that make this hard, and I think none is harder than what you have pointed to, which is intertemporal choice. That is, how can we get people to make decisions now that will affect our future? And we see this difficulty in everything, that we would rather eat donuts than go exercise, or the difficulties that we have in terms of that 80% of the people with hypertension don't have their hypertension controlled globally. That it's very hard for us, even as individuals, to take actions for the future. And then we also have a political system that you are rewarded for what is seen during your time in office, a much shorter time frame. And then this is even further compounded because we're talking about preventative steps. So they're harder to see. So I think that addressing this constructively really requires that we take this challenge of intertemporal choice seriously and think about how we work within this constraint. To me, some of the most exciting work in this area has to do with what is called episodic prospection. That is to think about a future and to think about a future that is a better future. And if people can be encouraged to think about how we could live as a community in solidarity on the planet and envision that it increases the willingness to engage in paying now for benefits later. So I do think that there's some work on the individual level that gets us focusing more on the future. And I think that we need to both implement that in terms of how we talk with folks, and then really work to get that deeper into the conversation and into the culture, so that as we also work with decision makers, they can also adopt that frame.
Thank you very much.
Thank you. Waiting, see if anybody else has any additional questions. I know Chris Woodle, the sobering and thought-provoking presentation. Thank you, Dr. Luby. And then Tariq also said, great presentation. Thank you. So we'll give everybody just a few more minutes to see if you want to drop any questions in the chat or raise your hand.
Maybe I can ask Chris, if he says it's sobering and thought-provoking, does he find it so sobering as to be disempowering? All right.
So Paige, I have a question, if that's okay.
Yeah, go ahead.
This is Paul McKinney. Again, thanks very much, Dr. Luby, for a really wonderful presentation, so provocative. I'm a person who's been thinking about many of these issues for a long time myself, and I've done a bit of reading books like Command and Control by Eric Schlossberg, who talked about near misses with nuclear weapons, things that could have gone horrifically wrong, but somehow didn't. The Doomsday Machine by Ellsberg, who talked about nuclear war planning and what the catastrophic results would have been, not just on the countries that were the recipients, if you will, the targets of nuclear weapons, but the adjacent countries as well, who have been kind of innocent bystanders. The Cobra event by Richard Preston talks about that synthetic pathogen that I believe that was combining flu and smallpox or something, was that one he envisioned, would be pretty horrific. And movies like Deus Ex Machina, that talked about robots gone amok that are endeavoring to kill humans and so forth. But I'm just wondering on the latter, with regard to artificial intelligence, do you think that it's possible to program the super intelligent systems that have not consciousness but a conscience, or that have a system of ethics built in that would restrict them from some sort of devastating action that could be catastrophic to the human race?
Yeah, so I think that we cannot stop the technological growth. Technology will continue to advance. It is inherent. And there are very strong incentives, because people can make a lot of money with artificial intelligence, that this is going to grow. So there are some who have argued we should stop and have policies by which we could stop the development towards artificial superintelligence. But I just think there's too much money to be made. There's too strong of an incentive. So I think that will happen. Now, can we put in some policies? Can we think about some things to make this safer? Should we be thinking about them? Yes. But I think your question gets at, are there things that we can do technologically to make artificial intelligence safer. And there is a growing, 10 years ago, I would say nascent, but now an increasingly active group looking at technical approaches to improve artificial intelligence safety. And one of the most prominent spokespeople is Stuart Russell, who is a professor of computer science at University of California, Berkeley, who has been the lead author on the leading textbook in artificial intelligence for decades. And he's been saying, now, wait a minute, I'm worried about where this is going. And so part of what needs to change is, instead of just saying we have an objective and now we're going to program the computer to implement this objective, is instead getting back and saying, how can we get programs to figure out how to behave? And there are a lot of different strategies. To me, one of the most promising is what's called inverse reinforcement learning, where computers are, where the program is asked to try to figure out what humans are trying to do. So instead of trying to just explicitly make it a goal, but in trying to figure out from human behavior, what are human goals and what would be human thriving and what is an appropriate lane to be driving in. And this work has actually contributed importantly to increased safety on self-driving cars, for example. So I do think it's a tough area to crack, and I think that we need to put a lot of heavy investment into AI safety. So when I think about government policy, like, I know the private industry are going to quickly figure out all the ways to make money, but investments in AI safety, good technical investments in AI safety, would benefit from research investments in that area. And I've talked about inverse reinforcement learning, but there are a number of other strategies thinking about how you can make computers so that as they achieve superintelligence, they would not have this misalignment problem. Of course, the concern is that they will become so capable that they are so distant from us that we don't have much of an interaction. On the other hand, most of the safety problems are really generated at the core. So as we develop this kind of technical thinking, I see as crucially important. And I think we can only avert the enormous threats that technology brings by deploying that very technology to try to make it safer.
Okay, and one very, very quick follow-up, if I can do that, ask you as well. And that is, perhaps a few decades ago, there were prominent professional organizations like Physicians for Social Responsibility that addressed these concerns of, major impacts on the future of the human race. We haven't heard much from them recently. Do you have any idea what happened to them or why people are not banding together to form groups like this now when the risk is so high?
Yeah, I think it seems to me that we have a system of disseminating news that is inherently disempowering, that we listen to all these terrible things that are happening and we're like, oh, ain't it awful? And then we put likes or we forward these things to other people. Yes, isn't this awful? I feel like we've become more spectators in the world than we have become active participants in the world. And I think that we do need to regain this sense of agency so that we do take action. And so sociologically, I just think we need to shift. I think it's less time listening to all of how terrible it is and more about thinking, what are the areas within my agency that I can control? And I think at the time of the Physicians for Social Responsibility and the Physicians Against Nuclear War, and these groups, they're still out there, but you're right, they're kind of remnants of themselves and they're not central as there. And it's part of the reason why I'm saying, wait a minute, these are central public health concerns. Are we going to have a human future in 2200? Let's be thinking about the threats and let's work on it.
Thank you very much.
Thank you. Looks like we have a couple, looks like a three-part question coming in here. To the point of being disempowering, there are certain things we can obviously tackle, like taking action towards climate change, but what can we do about nuclear proliferation? Can you point us to any resources that can help us wrap our brains around action about this issue?
Yeah, so if you look at the leading theorists on nuclear war, there are clearly some steps we could take that would reduce this risk. I don't think that we can ever go back to not having any nuclear weapons. I wish we could, but we've already developed them so that even if we could put them away, they would be too easy to reinvent and redeploy. But there are clear steps we could take that would reduce risks. So one would be to eliminate our intercontinental ballistic missile systems. William Perry, former Secretary of Defense, and most thinkers argue that these do not contribute to deterrence. They're not helpful, and yet they cost an enormous amount of money, and there is a concern that they may be misinterpreted as a grave threat. And some of these close calls have been because of perceived intercontinental ballistic missiles coming in. So one thing we could do is to say, let's save the money of upgrading ICBMs and eliminating them. It doesn't change our deterrent capacity because we still have submarine nuclear weapons, and we still have other key, and we still have fighter planes. So it just reduces risk. Similarly, the US could renounce that a policy of preemptive nuclear strike. That is, that they are saying as a policy, we will not be first strike. So those are both of these are political decisions. These are political decisions that could reduce risk. And as we talk about, like, how are we going to face climate change? How are we going to face all of these other problems? We actually could increase our federal budget by spending money more wisely instead of spending it to upgrade systems that aren't contributing to the human future, and spend it differently. And so I think part of this is increasing the sophistication of the conversation around these issues so that we can demand better policy from our lawmakers.
Thank you. And then it looks like Dr. LaJoy has another one here. He said, popular fiction such as Star Trek envision a future that overcomes some of the challenges you mentioned. However, apocryphal fiction seems most popular today. Do you think we are approaching a point where we are mostly abandoning hopes for the future?
Yeah. Well, first I would say, I think that it's useful for us to have science fiction, and it's useful for us to have stories so that we can think differently and think about what the future may bring. I do think, and I'm really impressed among students, the young people, particularly undergraduates that I engage with, are profoundly pessimistic about the future in ways that Paul and my generation was not. I think much of this is driven by climate change, but also this sense of lacking agency. So I think that if we resign into spectator mode, we actually reinforce the disempowering narrative. We actually make it true if we don't engage. So I do think that that this is a genuine threat, that that we are abandoning hopes for the future. And I would call on us in public health to think about the human future and to think about what we could do to encourage us getting to a better and a thriving place. And part of that is engaging in constructive conversation with the younger generation and encouraging them to take actions. And no one person is going to be able to avert all of this. but within their area of influence, one at a time, there are ways that we can reduce these threats. And so I do think that cynicism and just just being totally discouraged is a real issue. And I think that that's part of how we have to face it. But I think that that's maybe even less well responded to with oratory or with fiction, and more with action that people actually can see themselves doing and feeling good about.
Thank you. I know we're running a few minutes over, so anyone that needs to step off to another meeting or for their day can go ahead. We really appreciate you taking the time to talk with us. This was a super interesting presentation. We are recording the presentation and we'll be posting it online here in the next day or so. So we will have that link to share out if anybody missed it or wants to reference it. And then I think we'll also have a copy of the slide deck as well if anybody requests that. So feel free to reach out to me. I will put my email in the chat. And it looks like, I believe we've answered everybody's questions. So again, thank you very much for taking the time to meet with us. I know we've thoroughly enjoyed this, and we will put all this online and share that with you accordingly.
Thanks a lot. Thanks for the opportunity.
Definitely. Thank you. Take care.
Bye-bye.